Let's consider an example here where a bank grants a $20 million loan to a cement factory. The factory gets into financial difficulties. The bank takes over and appoints a consultant to find some solutions. After careful review, the consultant recommends several options. Option 1, invest an additional $8 million. The consequences, if successful, which is estimated to be a 65% probability, the benefits would be recovery of the loan plus the new investment plus a $5 million bonus. On the other hand, if they're not successful, they would be forced into bankruptcy with some salvage value, which is estimated at either $8 million or $4 million. Now, option 2 is not to invest any money. Let's see what the consequences are. First, there is a 40% probability that the government would acquire this factory because of employment requirements. And there is a 10% chance that they would be successful in turning it around. And if they do succeed, they will pay the debt. And if they fail, there are no obligations. It is also estimated that there's a 30% probability that a competitor would acquire this company for $5 million. The consequences, there's an 80% chance of success because they know the business. And if they do succeed, they will pay the debt plus a $15 million bonus. Of course, here again, no obligations if they fail. If neither of these materializes, then they would be forced into bankruptcy with the consequences as outlined before. The question is, what should the bank do? Invest or not invest? Let's draw the decision tree. We start with the decision node and we have the two options, invest or do not invest. And if we invest, we might recover or we might be forced into bankruptcy. Here are the salvage values. Similarly, we have three possible outcomes here: competitor acquisition, government acquisition, or bankruptcy, all of them with their own consequences. So this is our manual decision tree. Let's now go ahead and look at the Excel application. This is the decision tree on our Excel app that represents the bank loan problem. As you can see, here's the investment, here is where we do not invest, here's the failure, and here are the three possible options. How you build this is a subject in a separate video. Looking at the zone map, the do not invest zone is to the left of the demarcation line and the invest zone is to the right of the demarcation line. And these distances tell you how much latitude you have to make an error. In other words, till the probability of the success of the investment drops from 65% to 50%, you are safe in investing in this case. Likewise, if the probability of the competitor acquiring increases to beyond 48%, then we should reevaluate our decision and probably not invest. So the power of decision trees, it allows you to consider the uncertainties associated with these types of investments. Once again, the zone mapping and decision tree building is a subject that we discuss in separate videos.